Assalamualaikum. For quiz 3, number 1, figure shows a 4 kilogram box placed on a frictionless plane inclined at 30 degrees with the horizontal connected to a 7 kilogram hanging box by a string that passes over a pulley. Sketch a free body diagram showing all the forces on the 4 kilogram and 7 kilogram box. Okay, free body diagram, how do you sketch? You want a free body diagram on the 4 kilogram first. So for 4 kilogram, what you have here is the normal force, and then you have a tension and also weight. How about for 7 kilogram box, what do you have here is the tension and also weight. So this one is considered as weight too. So this is M2, while this for 4 kilogram is M1, so W1 lah here. Okay, so this is free body diagram for 4 kilogram and also 7 kilogram separately. Number 2, by referring question 1, calculate the acceleration of the system. So from the free body diagram, you can for the first M1, okay, 4 kilograms, so you can use a summation fx is equal to ma, and then here is a t minus w1 equal to m1a. Okay, and your t is actually w1x, is t minus mg sine sudut dia 30 degree equal to m1a. So substitute value t minus 4g sine 30 degree equal to 4a. So this will be the first equation. And then for your second equation, we can take from M2, which is 7 kilogram, and it is from the component of summation fy equal to ma. So here will be w2 minus t equal to m2a. And then what do you have here? Okay, actually you will have m2g minus t equal to m2a. Okay, then here you will have what? Substitute value 7g minus t equal to 7a. So this will be second equation. So from that part, so we take equation 1 plus 2 and then it will be negative 4g sine 30 degree plus 7g equal to 11a. So you calculate, you will get your acceleration, which is 4.46 meter per second squared. Okay, for number 3, so what do you have here? You have a mass m of 5 kilogram is suspended by a rope of length 2 meters, and then a force of 45 newton in the horizontal direction is applied at the midpoint R as shown. What is the angle theta the rope makes with the vertical in equilibrium? Okay, and you can neglect the mass of the rope. Okay, first of all, what you have to do is draw a free body diagram. So your free body diagram will be, okay, you have a T there, tension, and then you have a force and weight. Okay, so now because it is in equilibrium, at equilibrium, so for at equilibrium, so your summation F will be equal to 0. Okay, so for the x component, summation Fx is equal to 0. What do you have here in x component? So you can resolve. This will be a theta. Here will be ty equal to t cos theta, while this for tx will be t sin theta. So for x component, jadi t sin theta equal to F. Okay, so you have two forces. So t sin theta will equal to 45. So this will be first equation, and second equation we can get from summation Fy equal to 0. So for y component, you have two forces, Ty and also W, opposite direction. So it will be T cos theta minus W equal to 0. Okay, so you get T cos theta equal to 5G. So this will be second equation. Okay, and then divide. Okay, divide first and second equation. One divide by 2, so you will get 1 t sin theta over t cos theta equal to 45 over 5G. Okay, so calculate, t will cancel, tangent, it will be tangent theta equal to 45 over 5G. So calculate your theta and you will get 42.5 degree. So this will be your answer. Number 4, a bag of mass 2 kg is placed on a rough inclined plane as shown in figure. It is released from rest, and after that it accelerates at a constant rate 4 meter per second squared. Determine the coefficient of kinetic friction for the bag. So first of all, you have to do is to draw a free body diagram, or you just sketch forces on the bag. So we have here N, normal force, and then you have W, weight, and also because it accelerates downward, so it has a frictional force here. Fk. So this is the acceleration downward. Okay, given here is the mass, which is 2 kg, and acceleration, which is 4 meter per second squared. So you want to determine the coefficient of kinetic friction. Okay, now we know that in y component, summation Fy will be equal to 0. So in y component, we have a normal force, and also we have a minus Wy, which will be equal to 0. So Wy here, we can resolve here. Wy, so your theta will be here 30 degree, and this is your Wx. Okay, so that n will be equal to mg cos 30 degree. Okay, because it will be adjacent, Wy will be adjacent, and then your hypotenuse is W. So your n will be, you can calculate it, 2 times 9.81 cos 30 degree, where you will get 16.99 Newton. Okay, and then next, in x component, so for x component, summation Fx will be equal to ma, because it has acceleration. And in your x component, what do you have there? Okay, you have Fx and also Wx. So you have two forces there. Okay, so Wx is the same direction as acceleration, so it will be Wx minus Fk, which will be equal to ma. Okay, so your Wx is mg sine theta minus mu k n, which is equal to ma. Okay, substitute all the value given. Mass is 2 kilogram, so times 9.81 times sine theta is 30 degree minus mu k, and your n, you just calculated it, which is 16.99 Newton, equal to 2 times 4. Okay, then you can calculate it, and you will get your mu k, or your coefficient of kinetic friction, which is 0.107.